Okay, we're going to solve an improper integral. This one goes from negative infinity to infinity. We've got x times e to the power of negative x squared. So when you have an improper integral like this, where you have negative infinity and infinity, you have to split it into two different integrals. The reason for that is because you have to ground it in some kind of real value, because you can't work directly with two infinities. So we could choose any value in between negative infinity and infinity, if you want to look at it as being in between, which it is. It is in between. So we've got 0 is what I'm going to work with. And here we go from 0 to infinity. What we have inside, of course, the integrand, is going to be the same. And we're adding these two portions. This one, we're cutting it off at 0, and this one, we're starting it at 0. And since we can't work directly with infinities, we're going to replace this with some variable t, and we're going to let the limit as t approaches negative infinity do our work here. Here, we do the same thing, the limit, and we may choose some other variable, perhaps s. The limit as s approaches infinity. It's not a 5, it's an s. Now we can just integrate. How do you integrate? Well, we let u equal negative x squared because that seems like it's the only thing that could work here. The derivative of this is going to be negative 2x dx. Solve for x dx because that's what we have inside. We have x and we have dx. So that's negative 1/2 du equals x dx. du. Now we could replace that. We could replace this thing from t to 0, the limit as t approaches negative infinity, and we have the negative 1/2 out here. We've got du, and we've got e to the u, because we let u be negative x squared. So when we integrate this, we just get e to the u times negative 1/2, and we're going from the bound from t to 0 as the limit of t goes to negative infinity. We have to replace this back with x, negative x squared, if we don't want to change the bounds. Since we didn't, we have to replace it with the x version of u. So now we have to actually plug these in. Plug in the upper bound and subtract the lower bound. So if we plug in the upper bound, we're going to get negative 0 squared. Anything to 0 is just 1. So we have negative 1/2 times 1 is negative 1/2. Then we subtract, plugging in t and letting the limit work on that. Because remember, we're taking the limit of this entire thing. Limit as t approaches negative infinity of this entire thing. This is just a constant, so it doesn't make a difference. It doesn't even have a t in there. But we apply it to this side, and we get, first of all, this is addition because we have two negatives. We apply it here, and what happens? Well, we have negative infinity squared. That gives us a positive infinity, but then we still have a negative. It gives us a negative infinity. If you have a negative exponent, that means that this is in the denominator. It's in the denominator, this e, and it's being taken to the power. It's being taken to infinity. And if something in the denominator, this e, is being taken to infinity in the denominator, it's going to go to 0, because it's just going to keep growing and growing and growing. And if something's divided by something that's infinite, it just becomes 0. So we have negative 1/2. But that's just one part. That's just this side of the integral. We still have to solve the other one, because you can't just say it converges and let this be your answer, because even if it converges, you would still have to find the other part and add them. And if it diverged, then you could stop right there, because it diverges. So with this one, it's going to be the same. It's going to be this exact same thing, because it's the same integrand. We're letting the limit just different bounds. The limit as s approaches infinity, and this is infinity instead of negative infinity, of negative 1/2 e to the negative x squared, and this one's going from 0 to s, with s going to infinity. So we first plug in s, and look, we're going to get the same situation, because if you have something infinite, you square it, it's still infinite. Take it to the negative, and it's in the denominator. That means e is in the denominator, and it's growing and growing and growing forever. So this is going to become 0. This is going to become 0, and we're going to subtract the version of that, which has the version of this which has 0 plugged in. And if we plug in 0 here, we're going to get positive 1/2. We're going to get positive 1/2 because we're double subtracting. So this converges. Negative 1/2 plus 1/2 converges to 0. Converges to 0.